Today we're going to find the area of a polar coordinate that has a loop. So let's find the area of the inner loop of r equals 2 sine theta minus 1. I wrote this a little bit backwards. It should be negative 1 plus sine theta. So when we go a over b, a is negative 1, b is 2. This is going to be less than 1, so we know that it has a loop. Because it's sine and it's positive, it's going to be the loop around the y-axis. The period is 2 pi. So let's look what this is going to look like. So remember sine, my magnitude is 2 and sine is an s. It starts at 0 and I make an s. Because it's negative 1, that means all the points have to be moved down 1. So we're transforming this graph down 1. So at the angle 0, my magnitude is negative 1. But because it's negative 1, that means it's going to go to the left. At pi over 2, my magnitude is 1. Okay. Went a little bit too fast there. So let's try this again. Okay, at pi, my magnitude is negative 1. So at pi is negative 1, so that means I'm going to be right here. At 3 pi over 2, my magnitude is 3. So instead of being here, it's going to be up here. And at 2 pi is negative 1. So that means I'm back here. So you can kind of see the picture of what it's going to look like and how my loop is going to look. Okay. So that's usually how we would graph it. So what we're trying to do is we're trying to find the area of the inner loop. So we're trying to find the area of this inner loop. Okay. The problem is that I have to know from where to go. So remember my formula to find the area of polars is going to be from alpha to beta of 1/2 r squared d theta. The problem is that I don't know where alpha and beta are going to be. So I'm going to be using both graphs to kind of see where the graph is. So if you look at the graph from 0 to pi, okay, so if we look at the graph from 0 to pi, that means that I started at 0, negative 1, so I started here, and then I went to pi over 2, 1, so 1 pi over 2, so right here. So I'm following this loop right here. Okay, so that's this part right here. If I continue, if I go from pi over 2 to pi, okay, so remember at pi I was at negative 1, so that means I'm over here. I'm going to go down there. Okay. What we need to do is we need to find these zeros. Okay, we need to find what these zeros are. That 0 is actually going to be right here. Because I don't really want this part of the graph. I want to start at 0 and move over. Okay. So this green part right here represents the second part of my graph. And again, notice that it ends at 0. So I do need to find what that is. So I just want to find the area from here to there. So I need to find the zeros. And notice what I want to be 0. I want my r to be 0. Because remember, this is the magnitude. This actually represents r. R is this part. So we want r to be 0. So we're going to set our equation equal to 0. So we're going to add 1 to both sides, divide by 2, and then take sine inverse. So I need to find sine inverse of 1/2. So if you look at the unit circle, that when sine is positive, the y value is going to occur in both quadrant 1 in quadrant 2. So I'm going to have pi over 6 and 5 pi over 6. So those are going to be my zeros. So that is this one. So this is pi over 6. This one is 5 pi over 6. These are called the polar tangents. Okay. So I'm going to be going from pi over 6 to 5 pi over 6. Okay, of 1/2 r squared d theta. And we're going to use a calculator to calculate this. So once we put this in our calculator, we get 0.5435.